Hey guys, alright, let's do the video for 5-3. Okay, so in this video, we're going to talk about converting from vertex to standard form. Alright, so vertex form and standard form. Standard form is y equals ax squared plus bx plus c, where c is our y-intercept and a is our stretch or shrink. Okay, we could convert that to y equals a x minus h squared plus k. Now the a is still the stretch or shrink as it was before, but h and k are our vertex coordinates. H and k is the same as x and y. Okay, so let's take a look at what we got going on here. I got 3 examples. Let's take a look at number 5. I purposely picked the ones with fractions because, I know you guys can get intimidated by them, and I don't want to see that. All right. So, just like we saw in 5-1, where I had to expand this because we had x squared, okay, or x plus 9 over 2 squared, I have that here too. And that's what I'm going to do. So I have x plus 9 over 2 squared minus 1 over 4. All right, I'm going to expand that. So that's x plus 9 over 2, x plus 9 over 2 minus 1 over 4. And now I have to distribute that. Now here comes my trusty friend, the calculator. Okay, just in case I need a little bit of help. All right, x times x is x squared. X times 9 over 2 is 9 over 2x. X times 9 over 2 is 9 over 2x. Then 9 over 2 times 9 over 2. Well, remember, fractions multiply across. So the numerator multiplies the numerator and the denominator multiplies the denominator. So that is positive 81 over 4 minus 1 over 4. Now I'm going to combine like terms. When I add fractions, the rule is a little bit different. I add the numerator and the denominator comes along for the ride. So 9 plus 9 is 18. So that's x, 18 over 2x. Plus, same rule for subtraction. I subtract the denominators and the denominator comes along for the ride. So 81 minus 1 is 80, and there's a 4. Well, okay, this is not looking so intimidating to me anymore. 18 divided by 2 is 9. And 80 divided by 4 is 20. And there it is in standard form. Now I'm going to answer the regular questions we typically answer. The vertex, okay, if I have y equals a x minus h squared plus k, right, keep in mind that's a negative there. So, and when I pull it out of this formula, when I pull it out, it becomes a positive. Same goes here. When I pull that 9 over 2 out, it becomes a negative. So my vertex is negative 9 over 2 and then 1 over 4. My slope to the first line is a, and there's nothing here, so I'm going to write in a little imaginary 1. So that's 1. So slope to the first line, slope to first line equals 1. The domain is the same. That's d equals negative infinity to infinity. The range, notice I didn't graph it. All right, but the range, I know this opens up, and I'll prove that, and we use the x value of the vertex. So y value of the vertex, excuse me. So I know it opens up and I use the y value of the vertex, so I could say negative 1 over 4 to infinity. And we'll test that. The axis of symmetry is the x value of the vertex, so negative 9 over 2. All right, and let's see, what's next? Decrease and increase. This one's really hard to do without the graphing it, so we're going to graph it. Okay, 9 over 2 is about 4.5. So 1, 2, 3, 4, and I'm going to say that's 9 over 2. 1/4 is 0.25, right? So that's here. So there's my vertex. Now the slope to the first line is 1, so I'm going to go up 1 over 1, up 1 over 1, and I am now going to, I guess I should move this over a little bit. There we go. I'm now going to draw my graph. Now keep in mind, this is more about direction. It's not about making a work of art here. We're just trying to get it so that, you can kind of answer these questions. It's not about complete accuracy. As long as you got it going the right way, you're in good shape. In other words, it's not opening down, it's not over here. It's where it kind of needs to be. That's good enough. Now, when I come from negative infinity towards the vertex, from negative infinity towards the vertex, it is decreasing. So from negative infinity to negative 9 over 2, it's decreasing. Then from negative 9 over 2 to infinity, it is increasing. There we go. Okay, next. Oops, this one's just 2 examples. This is the last one. All right. Bonus. So, now I got this here fraction, right? And on top of that, I have to convert this to vertex form. It's hard to get the vertex out of this, okay? So the domain and the range, maybe you could figure it out, but it's really hard to do without the vertex, actually, because you need the part of the vertex to do it. So I'm going to convert this to the vertex. So I got vertex form. So I got 1/2 x squared minus 4x plus 10. I'm going to use the formula for the axis of symmetry to get the vertex, x value of the vertex. Since the guy is going up and down, the axis of symmetry is on the x-axis, so I can say x equals negative b over 2a. And this is b, and that's a. So I'm going to say negative 4 times 2 times 1/2. All right, 2 times 1/2. Remember what we said. I put a 1 under here. The numerator multiplies the numerator. Denominator multiplies the denominator. So I'm going to get negative 4, 2 over 2. What's 2 over 2 is 1. So I'm going to get negative 4. This here is the x value of the vertex. Now I got to plug that in. So I'm going to draw my little plug. All right, we're going to put a little negative 4 in it, and we're going to plug that right into here. So now I have y equals 1/2 4 squared minus 4 times, that's negative 4. Got to be careful there. That's negative 4 plus 10. This is how I'm going to get the y value of the vertex. Now you think, even though I could, you think I'm going to go and just try to figure this all out by hand, but I'm not. This is where the fancy calculator comes in. I'm just going to plug it in exactly as I see it. That's negative 4 squared plus, minus 4, negative 4 plus 10. And the answer I got was 34. So y equals 34. This is the y value of the vertex. Okay, so now I have my vertex, which I could answer that question right here. My vertex is negative 4, 34. Okay. Now, remember before I told you that's h and k? Well, here we go. I could just plug that right into here. Y equals, a, x minus h squared plus k. I plug that guy right in. He goes there, and he goes there. So y equals, and the a is still the same, so 1/2 x, because that's a negative, that becomes plus 4 plus 34. Now, remember what I said before. If you notice that y value is 34, then that takes it off into the next zip code. But really what I need to know is I just need to know general information to answer these questions. So, you know what? I know this is 4, and I'm just going to throw that right there. I'm going to say that's 34. I could make that rule up. I just called that 34. Okay? I know that it opens up. So, it's going this way. And that's really all I need to know, because the slope to the first line, slope to first line is 1/2. Okay, I'm going to write it up here. It's getting a little crowded down there. This is 1/2. The domain is negative infinity to positive infinity. The range is the y value of the vertex up, so 34 to infinity. I'm going to put a bracket around that, 34 to infinity. Axis of symmetry is the x value of the vertex. X equals -4. As I go from negative infinity to -4, it is decreasing. So from negative infinity to -4. And as I go from -4 to positive infinity, it is increasing. Okay, and that's that. All right, guys. I hope you guys found this video helpful.